With the advent of various deep learning frameworks, we can easily create deep learning models, vital elements of AI applications. We can deploy and use them on a hardware platform embedding various processing units according to their use cases. Hardware platforms are equipped with processing units such as CPU, GPU, NPU, and TPU. By taking full advantage of the power of these processing units, we can run deep learning models faster and more energy efficiently on hardware platforms. We should take full advantage of the performance of various hardware to run a deep learning model efficiently, so transforming deep learning operations into code optimized for the architecture of each hardware is essential. However, generating executable machine code optimized for specific hardware is a time-consuming and challenging task, even for experienced developers. The Deep Learning Compilation Framework is a development environment that automatically performs these optimizations to support the fast deployment of deep learning models. It is a set of tools and libraries that improve the productivity of developing high-performance deep learning applications by automatically generating executable code on specific hardware from a deep learning model. Next-C is a deep learning compilation framework developed by Etri. Different from existing deep learning compilers that generate machine code for only a single processing unit. Next-C can transform a single deep learning model into high-performance embedded system code that simultaneously utilizes the heterogeneous multiple processing units contained in the embedded system. Next-C applies various optimization techniques to generate machine code for high-performance processing units, especially NPU. Main optimization techniques include hardware-independent optimization techniques such as quantization, layer fusion, and operator scheduling, and hardware-dependent optimization techniques like latency hiding and auto-tuning. Next-C provides various tools for developers based on hardware-independent and hardware-dependent optimization techniques. Next-C provides a C-code gen tool generating C code from deep learning models. It also provides partition tuner automatically generating machine code and scheduling code. These codes utilize multiple heterogeneous processing units included in the embedded system. Besides, the relay code generator generates relay codes for TVM. Interpreter and multi-level NPU simulator can verify the correctness of compiler and compiled code at graph level, operator level, and NPU instruction level. And there is a performance profiling and monitoring tool that collects and visualizes the performance and resource utilization status of the running embedding system. Partition tuner uses profiling and monitoring tools that partition deep learning models to operate effectively using multiple heterogeneous processing units simultaneously. To infer a single deep learning model optimally on a single NPU, you can use the executable binary generated by Next-C. However, when there are multiple NPUs, it is necessary to distribute the inferences of a neural net model to multiple NPUs. The operating system targeted for this is NestOS. NestOS supports distributing inferences of multiple deep learning models to multiple NPUs in the form of tasks that are abstracted units of the deep learning model. In addition, NestOS supports the ability to load the training kernel of the deep learning model on a specific NPU before inferring the deep learning model or remove it when unnecessary afterward. When a deep learning model consists of multiple partitions, NestOS can abstract each one into subtasks for distributed execution on NPUs. Therefore, NestOS can improve performance by efficiently distributing and executing each partition of a deep learning model on multiple NPUs. In NestOS, the basic execution unit of deep learning model inference becomes a task. In a multitask execution environment where multiple NPUs execute various tasks simultaneously, you can fine-tune the execution order and location by changing the internal properties of tasks, such as task priority and NPU affinity. Nest-C and Nest OS are open source platforms and anyone can use them freely.